Welcome to an exploration of the invisible forces that make life on Earth possible. We call it Earth's invisible shield. Imagine this. What would happen if Earth's protective layers vanished for just one day? It's a thought experiment that reveals just how fragile our existence is. Earth is not just lucky, it's perfectly positioned within the sun's habitable zone, combined with essential protective systems that make it uniquely suited for sustaining life. Our first and most ancient defense begins deep inside the planet, the powerful Earth's magnetic field. This magnetic field is generated by the churning liquid iron outer core, a process known as the dynamo effect. This creates a planet-sized magnetic field, our primary defense. The magnetosphere is the bubble of space controlled by our magnetic field. It extends tens of thousands of kilometers into space, acting as the first line of defense against the fierce solar wind. Beyond the core shield, we have further celestial defenses, including the Van Allen belts and the constant fight against solar radiation. The Van Allen radiation belts are gigantic layers of charged particles trapped by the magnetosphere. They are crucial for absorbing and holding onto high-energy cosmic rays and solar particles, preventing them from reaching the surface. Every second, the sun bombards Earth with the solar wind, a stream of highly charged particles. Our magnetic shield works relentlessly to deflect this constant bombardment, ensuring the safety of all biological life. Next, let's explore the blanket of gases that keeps us warm and protects us from meteors and the sun's most damaging light, the atmosphere and the ozone layer. Our atmosphere is divided into distinct layers, each playing a role in protection and climate regulation. The ionosphere, a highly charged layer, is vital for radio communications and absorbing high-energy solar radiation. Nestled within the stratosphere, the ozone layer is Earth's natural sunscreen. It absorbs almost all of the sun's high-frequency ultraviolet light, protecting us from severe DNA damage, skin cancer, and crop failure. What happens when the sun gets angry? Let's trace the journey of a solar storm, a phenomenon that tests all of Earth's protective systems at once. When a coronal mass ejection, or CME, hits the Earth, its supercharged particles first collide with the magnetosphere. Most of the particles are harmlessly diverted around the planet, like water around a boulder. Only a tiny fraction of the charged particles sneak past the magnetosphere and funnel down the magnetic field lines near the poles, causing the nitrogen and oxygen in our atmosphere to glow. This is how we get the beautiful auroras. Beyond space threats, Earth has internal systems dedicated to keeping temperatures stable, our intricate climate regulation systems. The water cycle is a colossal heat distribution mechanism. It absorbs and transports thermal energy from the sun and redistributes it globally, ensuring no region becomes permanently uninhabitable. Our oceans act as the world's greatest heat buffer. Water's high specific heat allows the oceans to absorb enormous amounts of solar energy, regulating global temperatures and keeping the climate stable over long periods. These natural defenses are powerful, but they are not impervious. They face growing threats, often from our own actions. Ozone depletion, primarily from CFCs, dangerously thins our UV shield. Simultaneously, atmospheric pollution, including greenhouse gases, interferes with the atmosphere's natural temperature regulation. Human activities, from industrial emissions to deforestation, stress these delicate natural systems. Climate change is perhaps the most significant interference with our planet's self-regulation mechanisms. So let's revisit that terrifying scenario. What would be the immediate consequences if our shield simply vanished?